right, folks, we'll get started in just a minute. How is everybody doing? All right. Hello, everyone. Thank you for joining us this afternoon. I know we are in probably the final stretch, and thank you for showing up in the afternoon. Hopefully, everybody had coffee. I definitely had a lot. So today's session is about Kubernetes networking, right? We'll be hearing from one of the biggest practitioners in Kubernetes networking, Shopify. The team is right up here. And we'll be talking about how we Shopify and what are the things Google has done on GKE to deliver a large-scale Kubernetes network itself. I will be joined on stage by Maxime Ginters from Shopify, who will be taking bulk of this session, talking about their experiences, the lessons learned, the good things and the bad, hopefully, right? And that will be some good key takeaways. I am Nikhil Kelshikar, Director of Product Management for GKE networking, as well as VPC networking and a few other areas in Google Cloud. So here is what you're going to hear. Number one, you're going to hear about the evolution of Kubernetes. It has come a long way, and the journey we have taken so far. We will talk about the current state of the art, maybe in the high level, about the GKE networking architecture. Then I'll pass it on to Maxime, and then I'll come back, do a few demos, talk about some of the new capabilities we are developing, and hopefully we'll have some time for Q&A right at the end. So with that, let's get started. Networking is a foundational part of GKE. Kubernetes has a very well-defined requirements which it has for networking from the infrastructure itself. GKE networking today is Kubernetes networking. It is built on that open source foundation. We endeavor to contribute heavily to the community and contribute upstream so that whatever we do on GKE is always consistent with various upstream versions. We also aim to keep GKE consistent with various different distributions of GKE or Kubernetes within GCP. That includes having the consistent data plane, consistent set of services on GKE and Google Distributed Cloud, whether it is edge, virtual, hosted, all the flavors. Secondly, GKE benefits a lot from being VPC native itself, which means it has a lot of out-of-the-box integration with the Google VPC itself, right? That allows you to have various VPC features, whether it be VPC flow logs, node-level firewalls, various other capabilities are available out of the box, which means when we scale our broader underlying VPC capabilities or features, you can inherit them and build a more scalable GKE cluster itself. GKE over the time has evolved to have a rich set of security features, services. Examples of those are rich network policies, which we'll hear a lot about today, ability to have unified ingress with GKE gateway, and out-of-the-box integration with various GCP services, such as networking services, such as Cloud Armor, Cloud DNS, which came out recently, Google Cloud Load Balancing, and a few more over time. We can continue to have much more better, tighter integration with GKE itself. But above everything else, what GKE brings for us is the best of cloud networking, along with the scale, the reliability of what GCP brings together for Kubernetes to have a very resilient, scalable distribution for you to run your Kubernetes workloads on. However, this has always been a journey, and I know many of you, including Shopify, has been on this journey with us for many, many years. Kubernetes has been around for 10 years, and it is one of the most widely deployed open source projects. Google has been on the forefront of being a good steward of Kubernetes and has been enabling the customers on GKE to get the best of Kubernetes. We started with the GA of Kubernetes in 2015, and a few years ago now, we introduced VPC native capabilities on GKE itself, which allowed us to bring many new innovations over time. The big step forward was when we introduced Data Plane v2, which is based on eBPF, and we'll talk a little bit more about it. But with this, we introduced a programmable data plane, which allowed us to actually bring a whole new category of features, open up new use cases of what we'll start seeing today on Kubernetes itself. With multi-cluster gateway, we can actually build more reliable services which can span across clusters, across regions. Recently, last year, we introduced capabilities like Network Function Optimizer, which introduces features like multi-networking, What that does is really bring high performance workloads which need network offloads, multiple networks, interfaces, all of these on GKE. And this year, we are rolling out lots more observability capabilities with Hubble and others. So let's take a look at the current architecture of GKE networking. It builds on the foundational networking services offered by the underlying cloud networking platform, right? It's the node-level networking which VPC networks are actually part of, right? It gives you integration with the underlying software-defined network to get VPC integration. You get services like network egress, cloud NAT, and of course, IP addressing. I know that's a top of mind for many of the, from an IP utilization perspective. IP address integration for nodes, for your services, for your pods. The GKE control plane is also tightly integrated with the Kubernetes control plane. The GKE control plane is tightly integrated with the GCE control plane to give you a very tight, seamless experience that enables new features, that enables more scale itself. Then you have the container network interface, the CNI. This is based on data plane v2, which enables pods to be fully routable within GCP itself. Data plane v2 is based on eBPF and Cilium. This enables us to create these new class of features like stateful network policies and observability. GKE exposes most of the capabilities with this stack as Kubernetes native features, or if a native Kubernetes capability is not available, as a Kubernetes enhancement proposal or KEP, so that it is always upstream compliant and you can look at the open source code, you can actually contribute back to it as well. Data plane v2 enables network policy at node level, and now we can also enable FQDN, or fully qualified domain name-based network policies. We also have the ability to introduce cluster-wide network policies, as well as cluster-wide node-to-node encryption with user-managed keys on GKE. And on top of this all, we bring together all the layer 7 services, tight integration with GCP load balancing, like our network endpoint groups. Now, with GKE Enterprise, with multi-cluster capabilities, with fleet management, we also have the ability to do multi-cluster services and multi-cluster gateway ingress, which can span not only across clusters, but across regions. Now, this, of course, is a very high-level view of the network architecture for GKE. But keep in mind, this is also the same foundational architecture which applies for Google Distributed Cloud, which is based on Kubernetes as well. So that means that wherever GKE runs, you can get a very consistent experience for your applications and services. Let's talk a little bit about cross-cloud network. Last year with GCP Cloud Networking, we announced cross-cloud network. The idea behind cross-cloud network is Google's network is built on a planet-scale foundation which spans everywhere. Cross-cloud network provides an open platform for many people to actually innovate on, to build extensions, ML-based security, and really performance optimized. Over 5,000 plus customers are benefiting from GCP's cross-cloud network, and almost 60% of the Fortune 50. As a quick recap, CCN enables 3 use cases. Number 1, enable us to build distributed applications which can span across clouds. Number 2, enable us to deliver services and applications to millions and billions of users around the world. And number 3, enables enterprises to connect to their own hybrid workloads, or enterprises to connect, users to connect to their workloads running inside the cloud itself, right? GKE enables all of these 3 use cases as an important part to play. For example, if you're building apps for training, GKE is now capable of enabling GPUs and TPUs with very, very high throughput and performance. If you're building SaaS services which you're hosting and serving to other customers, GKE has native integrations to build those SaaS services with things such as Private Service Connect, which enable you to put service endpoints which your consumers, your customers can access. We are introducing, this morning we talked about new load balancing enhancements, which will enable AI/ML serving to be much more efficient, with being able to put in custom metrics which look at utilization and serving latency for being able to serve using GPUs and TPUs. Having a unified security and services framework for delivering different kind of apps, whether it is gaming or things like Shopify reaching billions of users, our global front end enables us to make that happen. And last but not the least, for hybrid workload and users, with various new innovations such as network function optimization, with multiple networks and service chaining capabilities, now networking in Kubernetes is becoming richer and richer, which means you can even run network functions such as a 5G core for delivering private 5G or telco services right on top of that GKE infrastructure. You can build complex SASE and security functions and firewalls and various custom security functions and host it on GKE to build SASE services to reach your end users. So this is a very powerful set of capabilities and use cases which GKE can now support. But I want to pass it for the main person over here, Maxime, to talk about how has Shopify benefited. Maxime, all yours.
Thank you. Hello, everyone. I'm Maxime. I'm a production engineer at Shopify. I mostly work with the teams responsible of running Kubernetes with us. First of all, what is Shopify? For those who don't know, we are an e-commerce company basically hosting a bunch of shops on the internet. To give you a sense of number, we have an event that you probably know about that it's called Black Friday and Cyber Monday that happens once a year. During that event, we scale everything up in order to absorb a peak of traffic. That peak of traffic represents like up to 9.3 billion in sale over that weekend. What does that mean for Kubernetes and our platform? The graph you see here is the total CPU cores available on our platform over a couple of weeks. And the spike you can see is that weekend. So what does that represent? Like it's written down there, 400 GKE clusters that we manage day to day, and over 35,000 VMs over that weekend. So how do we achieve that? So we went through quite a journey from first being in data centers and moving to the cloud, and then through various VPC topology iteration, and finally a move to data plane v2. So let's go through that. 2017, 2018, we were running in data centers, so 2 co-located locations, and well, we're not satisfied anymore with that, and we had to move for various reasons. So we picked Google Cloud back then, and we moved to a pretty simple tiered architecture. So we had a tier 4 to tier 1 VPCs with more or less 1 GKE cluster in each of them. Not exactly, but more or less. And we ran with that for some time. We moved all the application. The clusters, as you can imagine, had co-located applications and backend services in some cases. And all of that lived in a single GCP project. Well, I hope you can see all the wrong thing with that. And we did as well. So we moved, starting from 2019, we started to see the problem coming up as we started to have more and more GKE clusters in there. So we moved to a new VPC topology, and we leveraged several Google features on that. First of all, the shared VPC. So that feature allowed to decorrelate where you run the network from where you run the workload. So typically, we could have a host project that runs and hosts the VPCs. And then each team underneath can have a dedicated project for them to run their GKE clusters. So typically for us, that allows to split the team that runs Kafka and runs the Kafka clusters can have their own project and run the things there, while another team won't be impacted by what they do in there, while still running on the same network. Concerning the network, one of the problems we had is because we had single VPCs with everything in there, and it became scary to do any change, because one bad change can block and break everything in that VPC. So we wanted more VPCs, but we want to keep the connectivity amongst them. This is where we introduced like Core 1 and Core 2 alike VPCs peer together that allows us to, when you have a change to roll out, we can roll it out to one end of it, see how it goes, roll back if we need, but we will not break everything at once. So to make that happen, one of the main problematic was you need to recreate all the GKE clusters. And I know you know it's painful. So we invested in a bunch of tooling to make that easy for us, to recreate the clusters, to move the application around between them, and to be able to do that efficiently. This is also when we started to not upgrade the clusters in place. We choose intentionally to, whenever we have an upgrade to make for a new version, we'll replace the cluster. Scrap the old one, make a new one, move the application over. So we ran that for some time. That works fine. But one thing that was started to coming up quite often is the lack of interconnectivity between the groups we had. Typically here, why do we have a Kafka group? It's because we need the apps end and the core end to talk both to Kafka. So we had to have a third group here, and communication was happening over public IPs. We wanted to introduce more regionality into that. So in 2021, that's where we moved to what we call regional VPC. Don't get me wrong, they are standard Google VPCs. There is no magic stuff for regional here. The only magic here, kind of, is we treat them regionally, meaning we'll spin up one VPC for a given region, and we'll only put workload of that region in that VPC. Why? So one thing we noticed is most of our traffic is what we call north-south. So it comes in from the load balancers, get into a region, and in most of the cases, it's processed entirely in that region. The cross-region traffic is an exception. It happens. We need to care for it, but we don't have to specifically design directly for it. So this is what we did. One VPC for each region. We peer them all together, and then the firewalling becomes easier. Managing the topology and the communication flow is easier. The one thing that were complex here, if you remember, I mentioned we ran 35,000 VMs for the last Black Friday, Cyber Monday event. And it was even worse in 2022. 2022 on N1 VMs, I think we're at 52,000. If you're aware of the VPC limits, that doesn't fit at all. So this is where we had to work with Google here to, hey, we want to fit a lot of VMs in your VPCs. And we would like to have that kind of topology. How can we do that with you? So we engage with Google. We work with them to find the right compromise on what can I put in your VPCs to be able to raise the limits for us. So a bunch of things we complied to. The limitation on the forwarding rule, the limitation on the IP forwarding features, and then we were able to achieve that. So since then, as you can imagine, we had to recreate again everything. And one thing we kind of figured out and adopt is all those changes happens during upgrade cycle. So every time we have to upgrade the fleet to a new GKE version, we try to align that kind of changes. So early 2021, I don't even remember, what was it? GKE 120 probably? We had to upgrade cycle for it. We just aligned double the VPC changes, and basically this went transparently for most users. They just recreate their cluster, it ends up somewhere else. They don't even know. We carry forward. Next on to, let's talk about the CNI, now that we're done with the VPC stuff. So, like I mentioned, we moved to data plane v2. What was there before? Well, quite easy. We used the default CNI on GKE, Calico, and that was a good companion for several years. It worked fine. We had several issues, nothing really groundbreaking and deal-breaking, except we wanted to stuff more things into a cluster. And it's not actually more shared things like a bunch of applications with a few replica. It's actually, imagine running 2 deployments in a cluster, but those 2 deployments have thousands of replica. This is where Calico kind of break down for us. It was slow to converge whenever you had a rollout. It had impact back to the Nginx layer in front of it and resulted in 502s, 504 during deployments. We found workaround, but wasn't never great. Second main issue for us was the network policy. Calico does support network policy. They work fine. It's OK. It's just we are totally blind on what's happening. So it will drop the packet, but you don't know why, for what workload, from where. So we looked into an alternative. Quite obviously, Cilium came up pretty right away as an option. We started to look into it in 2021. Originally, we tried to run Cilium itself, the upstream version, on Gkey, on Google. That worked, but that was a lot of maintenance. That was a lot of workaround, a lot of messing around with node pool and the node selectors and the taint to have it installed in the right way to work. And back then, we didn't have enough reason to move, to get it. So we kind of put that on the shelf for some time. Then, the end of 2022, our infrastructure security folks had network policy issues. And they wanted to see what was happening. They wanted to have more data. They wanted to graph the network policy, the drops, to be able to troubleshoot when something is happening. So we had the solution for them. And this is where, again, we engage with Google on, look, we want Cilium, but we don't want to run it. The team running that I work with, it's like 7, 8 people running Kubernetes as a whole for the company. We can't run the CNI on our own. So, hey, Google, can we work with you on this? So we worked with Google. We started to use Dataplan v2, and obviously the deal for us was, hey, I can just click on a checkbox. I have Cilium. So we ran some experiments. It was OK. It worked fine. We had what we wanted, the network policy logging. We had a better convergence on the large deployment. That's cool. So again, Gkey upgrade cycle. Back then, it was Gkey 124. Last year, turn on the checkbox. Every new cluster that comes up is going to have Cilium, Dataplan v2. And after a few months, it's all rolled out slowly. Cool. That's a done deal. I can close my talk, and we're done here. Except that. This is not what happened. We had a few issues. Surprise. First of all, let's talk about Hubble. Hubble is great. Hubble is a great piece of software that will help you troubleshoot and know what's happening on your platform. Except it has a cost, has a performance cost. When we first ran Dataplan v2 on our clusters, only by default back then, only the network policy logging was enabled. So only in the logs you will find the outcome. Well, we wanted metrics. So we went into the config map, enabled the metric endpoint, and this happened. Guess where we enabled the metric endpoint? So what happened here? By default, Hubble will log network policy drops and flows. When you run that in production with thousands of nodes, thousands of pods, endpoints, and a large cardinality of source and destination, that's a lot of logs and a lot of metrics. So what you see here is the CPU and the memory consumption of Hubble as soon as we enable the metrics. And what actually happened behind that is the metric endpoint exposing the metrics just got crazy huge. So we found that problem. We looked into our options. The way Hubble works is it shares, there is a socket that the Cilium agent on every node expose, where it will push all those events for consumption. You can write your own client and consume it if you want. Hubble is such client. So Hubble read those events and expose them, do something with them. The one nice thing, though, on each of those events, the first byte is the type of event. So you don't even have to decipher the whole event to know what it is. So what we did is pretty straightforward. We went to Cilium upstream, made a PR to ask, hey, can we ignore some events? Can we just process the network policy drop event, and this is the only thing we want to expose? PR came up upstream, got accepted. We engaged with Google to, hey, can we backport that, please? We got the fix in, we enabled it, and right away, CPU was fine, memory was fine, and we can carry on. We have our network policy logging, and we don't lose on performance. The second one is a bit more tricky, so bear with me here. I will try to simplify that. We found a bug with the way Cilium interact and process identities. As soon as we changed the label on a namespace, it reassigned the identity on the workload within that namespace. When this happens, the identity has to shift from one Cilium endpoint slice to CRD to another one. So this is what we see here. It's two different Cilium endpoint slices for the same IP. But we can see that the ID up top is different, so it's a new identity. Cool. How does that work normally? The identity is used to identify workload within your cluster, and then use network policy to say, this thing can talk to that other thing. Internally in the BPF map, it will know that, hey, this identity can talk to this identity, let it go. The mapping of an IP to an identity is stored in a BPF map called the IP cache. And whenever a packet comes in on the wire, it goes into the IP cache. Please give me the identity for that thing, for the source and the destination, match them together, and let it pass or not. With that bug, when the the identity got translated from one slice to another, race condition happens, it got out of the IP cache. So basically, any packet that goes out afterward or in, for those workloads, we were not able to know what was the identity. And this is what we see here with the identity 2, which is the world identity, meaning outside of the cluster. And guess what infrastructure security folks do? They drop the traffic from outside of the cluster. So we just dropped all of our traffic. We engaged with Google on this one. We worked on two fronts, one being fixing on the short term. So we found a way to implement a controller that plays a bit with the CRDs to trigger the update on the nodes and fix the problem. And on the other end, Google actually dive into that problem with us. And they found the root cause. They found a fix. They did upstream it, and they did get it back right away on our clusters with a fixed version directly for us on our workloads, as well as making it for the next version and the next release of Gkey. So that's fixed. So what did we win? What did we get out of that upline v2? The main obvious one, performance. It's a different game. The convergence of all the CRDs, mainly the endpoints object, the endpoints and endpoint slice object, the convergence of that when you deploy a large deployment is unparalleled. So no more 502, 504 from an Nginx waiting on the endpoints to be updated. One thing we didn't especially wanted, but we got, for free was the Cilium redirect, local redirect policy. We run our own core DNS. We run a node local core DNS deployment, and we had hacks to make it work. We were hacking, hijacking IP table, injecting stuff to make it work. Well, we now have a standard CRD that does that for us. It's more clean. And the second one, the reason we moved to Data Plane v2 first M, network policies. We have the logging and the metrics. We have Hubble. It's now supported directly by Google, and I'll actually try it. It's really cool. It helps us whenever there is an incident, whenever something happens, to actually go and troubleshoot and find the actual problem. And most of the case, it's a human that did something wrong, and we want to know about it. And next, but not last, FQDN-based network policy or infrastructure security people will be looking into that next. That's the one thing they wanted to the most out of all of that. A couple of takeaways for today. If you followed through, one of the things that saved us through that journey is we always treated GKE clusters as cattle, not pets. Meaning, whenever we had a new feature to roll out, a new things to change, that's fine. Just scrub it all, put new ones, move the workloads over, and move on. Actually, as an inside joke, we even talked about having just hash as in the name for the clusters, not to actually refer them anywhere. We didn't do that, but maybe someday. Then one I maybe didn't touch upon a lot, but is still relevant here, the workload segregation. We do run databases on Kubernetes, but we run them aside on different clusters, meaning we have stateful clusters and stateless clusters. You can very easily move the stateless ones, and because it's owned by different teams, there is no conflict when it's the upgrade time. There is not much synchronization to have between the teams and all of that. So it's a clear contract and boundaries between all of them. And last one, iterate. You can see that we went through a bunch of iteration of our thing. We will most likely have another one because new things will come up, new business need will come. And back then, the other one were the best answer at that time. Maybe that best answer is not the right one anymore, but be ready to change that. Challenge your assumptions. That's it for me. Hope you liked it. I'm going to hand it over to Nikhil. Thank you.
All right. Thank you, Maxime, and thank you to the Shopify team for paving the way for many people in the community, helping us, giving us valuable feedback and making Data Plane v2 and many of these migrations successful, right? We heard a lot about Data Plane v2, so let's talk a little bit about it, right? Data Plane v2 under the hoods has components which run in the kernel, things which run in the user space, as well as controllers which are able to program this. With Data Plane v2, we can enable a new set of capabilities, as I talked before. Multi-networking, stateful pod-level network policy, rich telemetry and visibility powered by Hubble, as Maxime just talked about, right? As well as cluster-wide policies. Today, Data Plane v2 is enabled by default for all new Autopilot clusters. Almost 95% of the GKE Autopilot fleet today is running Data Plane v2. And as more and more customers migrate to DPv2, create new clusters, you can get a lot of these new capabilities. We encourage you to adopt it for new clusters so you can get some of the benefits. You can actually operationally make it much better, faster, and greater for yourself as well. So now I'm going to switch over and show you the observability pieces which Maxime talked about. I created a demo of observability, but it's mostly screenshots, so it's easy for us to follow along. So first, you have to enable Hubble for your clusters itself. Now, in this case, some of the Hubble and the observability capabilities are part of GKE Enterprise, but it is available right now for many users. We have shown an example of a network policy which allows you to, which is applied to the shipping service label and only allows pods with the label front end to talk to the shipping service itself. So that's the network policy. Now let's take a look at the next piece. You can go into the monitoring integrations in your G Cloud console and then enable GKE integration itself. Next, you can go to monitoring dashboards and look at data plane V2 observability, right, for the cluster flows overview. And over here, right at the bottom, if you look at the cluster filter for that exact specific project, in this case, it is GKE network observability demo, you see that there are some denied flows. At this point, clearly there is something which is not working, misconfigured, needs more investigation, right? So you can dive a little bit deeper into this. We can go into the drill down view, where you can look at source and dest directions itself, and look at the workload shipping service. There are lots of these fine-grained filters which are available. And this shows us that there are a counter policy denied is between the checkout service and the shipping service. So now we can go solve that problem if that's a problem worth solving. Now, we showed you the dashboard view. This is also available. Most likely, most practitioners will solve it with the Hubble CLI, which is also enabled by default, which is also enabled once you start the Hubble, but you also have the dashboard view. Another way to actually look at some of these things is also through the network intelligence view. If you go to network topology and you look at the GKE tab, you can select various metrics. One of those metrics in this case is the network verdict. It is the network policy verdict for drop flows. For the same cluster, it will show you very easily where the drop flows are. And unfortunately, because of the projector, you can't actually see it very well on the screen. But there are lines there between the shipping service and the front end. And you can see that there are certain flows which are actually getting dropped. And it is quite easy from a graphical view. So there are various ways you can actually make observability more easier, more accessible, more powerful. Let's look at the service topology which Hubble enables. And I'm afraid like the lines are, we'll see. So in this case, you can go to the network verdict, pick a cluster, and look at the most forwarded flows in the network intelligence center topology view. By default, it will sort by the highest flows, but you can pick a particular cluster. And it will show you, in this case, for example, we are checking the front-end cluster, and it will show you really the various workloads and how they are communicating with each other, which namespaces are talking to each other, where are the communications. You click on any one of these, and you can drill down on the right-hand side panel, and it will show you the ingress, egress flow directions and various different parameters and policy verdicts. You can further drill down from these topology views right down into the workloads, the pods within the namespace itself. So now you, what you're getting with the foundation we built with Data Plane V2 is a rich set of observability, visualization, other capabilities, and which can be parsed in multiple different ways. So I will click past this demo here and hopefully talk about the next thing. All right. GKE also offers many VPC native capabilities. Out-of-the-box integration with Private Service Connect enables access today for GKE Flex clusters to connect from GKE master to your GKE cluster itself, right? Enabling scale. We have integrated tightly as with VPC networking. So as Maxime mentioned, you can have this architecture of many smaller, many more VPCs, which are maybe regional in scope, maybe global in scope, however you want to. But you can use Network Connectivity Center now with various VPC spokes, which are available today, to be able to pair a large number of VPCs together, actually connect them as VPC spokes. This scale can now exceed from the smaller numbers of 50 to like 250, and we are actually enabling more and more scale, which gives you various different dimensions in how you can start building larger scalable systems itself. IP address exhaustion has been, and how to manage IPs in GKE has been a top concern. We have clearly built various different features to like multi-nodes, multi-pod CIDR, and secondary ranges and things like that to help make that easy. Currently, IPv6 dual stack is available on GKE, and there are various design paradigms to enable you to manage IP exhaustion. And in the future, we are looking soon to introduce IPv6 single stack capabilities as well, which Maxime reminded me is very, very important. So, of course, let me go back. I would be remiss if I did not show you what we are doing with Gemini on GKE. So for IPs, we can click and look at answering some very simple questions. How many IPs do I need? What is the range I need, range of a pod IP range I need for my GKE new cluster which I'm establishing? So right there, you see the Gemini assist alert. You can form the question out of context, capture the context, and place it into Gemini itself on the side. And the question here is, do I have enough IPs? And it does the analysis based on how many nodes you're trying to look at, how many pods you want per node, looks at the IP array ranges which are available to you, and can give you and recommend CIDR ranges which you can apply for your cluster. So that's some of those tasks which require manual spreadsheets and things to actually manage and maintain. We are enabling with this. And over time, we'll make it richer and richer with many more assist capabilities built into GKE itself. Here's another one. You want to look at what is my utilization of IPs per particular node look like? Well, ask Gemini. It takes the context of the cluster. It knows what the cluster is. And it can go run the analysis and say, hey, well, you have these two node pools. One node pool is running at 100%, and the second node pool is running, has some space available. So that's what your utilization looks like. So you can get a lot of these insights through Gemini as we continue to plug and integrate these platforms together. A few more interesting features I want to highlight. Network Function Optimizer came out in late 2023. Enables multi-networking, as we spoke about. What does that mean? That means you can now have multiple network interfaces. If you're running network functions, you want a control plane network interface, you want a data plane interface, and maybe you also want a very high performance interface for network offloads. You can have these things. We're also introducing a high performance data plane, right? So in the future, when there are things for GPUs and things which enable you RDMA or fast track and these access, we can deliver high IO bandwidth to GPUs. We can do kernel pass-through using DPDK, AFXDP modes, right? So enabling you to build highly performance-capable, performance-sensitive applications on top of GKE, enabling a new class of use cases for your business. Another common use case we see in the telco world is about having persistent IPs, because these IPs are pertinent to the business logic of the application itself. So you can have nodes with those persistent IPs, and we can do fast failover of those IPs to a secondary node itself, right? Enabling you to have like sub-second convergence for your entire system itself, which is critical if you're running network functions or security functions. You don't want to wait for these failure timers to expire. And the ability to stitch various different container network functions in the data path itself, right? So you can have various traffic classifiers, and you can chain the functions. So you can now build complex security, monitoring, compliance functions in your data path. Many of these things required you to basically do things in the physical network, but now you can do that all with virtual functions and network functions running on top of your Kubernetes cluster itself. So that is Network Function Optimizer, which is now available. GKE Gateway is available, which is enables us to have various unify various ingress APIs between mesh and Kubernetes onto a common infrastructure. The problem was with ingress, it is has been the default implementation for Kubernetes over the years. But it got a little complex to manage because of the various different personas who are starting to use GKE itself. Gateway gives us that new API, which allows you to unify the ingress API, enable you to use service meshes consistently, and even have cluster IP services. GKE Gateway is our implementation of the open source Gateway API on GKE through our Gateway controllers, and can give you various set of abstractions, right? And with this, you can also start building various multi-cluster gateways and multi-cluster services itself. Multi-cluster services enable you to basically have clusters which span regions and build better reliability for your applications. You can still treat them as cattle, as Maxime said, but yet provide a very, very high level of SLO and SLA for the services you provide your customers. Many of these services, NFO, multi-cluster services, multi-cluster gateway, are a part of the GKE enterprise capabilities itself. MCS is an open source API, as you know, and we continue to invest in that area. I'm almost at time, so some few key takeaways. GKE networking provides you a rich VPC networking native foundation for Kubernetes. Today, we are enabling a new class of workloads for GKE and enabling a rich set of services. I hope you get some of these new innovations a try, and thank you for joining us. And I'm at time, and I want to thank Maxime as well, my partner in crime here, for this great session. Thank you.